A rectangular pool 6 meters by 8 meters is surrounded by a walkway of width x meters. This problem has to do with the rectangular region taken up by the pool and walkway. So first, let's go ahead and draw a picture. So it says we have a pool that is 6 meters by 8 meters. So 6 by 8. I'm going to go ahead and calculate the area of that because we will need that in just a second. So 48 square meters is the area of the pool. And then it's surrounded by a walkway. So the walkway is going to go on all 4 sides. And this walkway has a width of x. So it's going to be x meters on every single side of the pool. So first we want to write, for part A, the length and the width in terms of x. So we're looking at this side here. This side is going to be 2x plus 8 because we have x plus 8 plus another x to get all the way across. Similarly, the height of this rectangle is going to be 2x plus 6 because we have x plus 6 plus another x to make that side. So we can say that part A, the length and width are 2x plus 6 and 2x plus 8. So then we're going to take those two dimensions and we want the area of the entire region, so including the pool. We're going to multiply out length times width, 2x plus 6 times 2x plus 8. When you distribute that out, combine your like terms, you end up getting 4x squared plus 28x plus 48. So we can say that the area of that region equals that value or that polynomial. Okay, so that's part B. Okay, what is the area of the full rectangular region when x equals 3? I'm going to leave you to do that on your own. You're just taking that equation that you got in part B, plugging in a 3, and solving for a numeric value. Part D, write this function in vertex form. So we're going to start with y equals 4x squared plus 28x plus 48. And if you recall, for vertex form, first thing we want to do is move that constant to the left. And I'm going to go ahead and factor out my a value on the right. So factor out that 4, you're left with x squared plus 7x. And then I wrote that blank in there. So that blank is going to be half of our b value. So 7 halves squared, which is equal to 49 over 4. So 49 over 4 is going to go in this blank over here. But remember, to add it to the left side, you're actually multiplying it by this value on the outside. So it's going to just be plus 49 because the 4 times 49 over 4 is going to cancel that out. So we have y plus 1 equals, the right side is going to factor as 4 parentheses x plus 7 halves squared. And then the final step to get that into vertex form is subtract the 1. So vertex form is y equals 4 parentheses x plus 7 halves squared minus 1. Okay, so that's going to answer part D. Sketch this graph in a reasonable domain. I'm going to leave you to the sketching on your own. But a reasonable domain would be any values of x that are greater than 0. Because we do have that walkway, it would not make sense for us to have a negative walkway. Okay, so besides drawing the picture, probably the part that's going to give you the most trouble is going to be part F. So once we set up part F, it's not going to be so bad. But for some reason, we always struggle with setting that up. So it says find the value of x, which makes the walkway have an area equal to the area of the pool. So like I said earlier, we're going to need the area of the pool, which we said is 48. Okay, so we want this to be equal to the area of the walkway. But if you recall, our area equation that we got up here includes the pool. So what we're going to have to do is subtract out the 48 of the pool to get just the walkway. So just the walkway has an area equation of 4x squared plus 28x. So this is the walkway. And we want that to be equal to 48, the area of the pool. So this is a quadratic. We want to get it into standard form in order to solve it. So I'm going to move that 48 over to the left equals 0. Now, one way, since all of these values are divisible by a 4, one way we can simplify this before we solve is to divide both sides by 4. This is just going to give us smaller numbers to work with. So x squared plus 7x minus 12 equals 0, because 0 divided by anything is still a 0. Unfortunately, this is not going to factor. You're going to have to use the quadratic formula to solve. I'm not going to do that plugging in for you. You're going to plug your A, B, and C in on your own, simplify. I will tell you, you're going to have to decipher, because remember, quadratic formula gives us two separate answers. When we add and when we subtract for the plus or minus, you're going to have to decipher which of those is the realistic solution based on what we talked about for part E.